All right, hello. This is video number 20. It is chapter 4, section 5. And this is all about graphing a system, which means more than one, of linear inequalities. And we've done individual linear inequalities in the past. Remember that requires a test point to determine if your statement's true or false. It also requires shading of the graph area that is true. So you're shading the true section. And also remember that if you have a less than or a greater than symbol, then you use a dotted line. And if you have a less than or equal to or greater than or equal to, you use a solid line when you graph. All right, so I have two examples prepared on the next couple slides from Varsity. This should actually be a fairly short and simple video. I do want to remind you of the quadrants. If this is your coordinate plane, this is quadrant 1, the positive quadrant, and then you go counterclockwise in a C shape. So quadrant 2, quadrant 3, quadrant 4, and that's a reminder for the vocabulary that's in Varsity. Okay? So here's the first question that I pulled to the side. And the first thing you want to notice is that your equations are not in slope-intercept form. So you need to be able to put them in slope-intercept form. Before going any further. And so I'll do the top one in red. We'll do this one here in red. So we have x plus y is less than or equal to 6. I'm going to move the x, which means I'm going to subtract it from both sides. So I have y is less than or equal to negative x plus 6, and that one's done. And then I'll do the bottom one in blue. So that's 2x minus y is less than or equal to 3. I'm going to move the 2x. So now I have negative y is less than or equal to negative 2x plus 3. And remember, when you divide by a negative, you need to flip that symbol. Right? So we now get a positive y is greater than or equal to 2x minus 3. And that's the equation that we're going to graph there. So I'll actually graph this one in green, the same color that we finished in. All right, so the first one, let me graph the line first. These both have greater than or equal to or less than or equal to symbols. So they're both going to be solid lines. So you would pick this tool in Varsity, right? The solid line tool over here. And remember, in Varsity, you have 3 points when you plot the line. You're going to put a point on the y-intercept. So let's do this first line right here. Y is less than or equal to negative x plus 6. You're going to put a point on the y-intercept. You're going to use the slope to plot a second line. So I'm going to go down one and over one. And that would give me a solid line through there. And then you need to know if you're shading the left or right side, and you put a point on that side. So let me real quickly, I'll choose my test point of 0, 0. I'm not going to review how to do this. I will link to the original video that explains that if you need that explanation. So I'm going to plug x and y in. So I have 0 plus 0 is less than or equal to 6. 0 is less than or equal to 6. So this is true. So we're going to shade the entire side of this that contains that point, because that test point will be here. So when you plot in Varsity, again, I'm going to do this in black over the top of what's there. Put a point at your y-intercept. Put the next point based on the slope. Your line will be created, and then move to the left or right side of the line and hover and just click on a point, and that will shade that whole part of that line for you in Varsity. All right, the green one, we're going to go down to negative 3, and then I'm going to go up to over 1 for my slope. So that would create this line right here. And then again, I'm going to make my test point 0, 0 because it's not on the line. Remember, your test point cannot be on the line. Okay, so that's just a reminder there. So we have 2x minus 0 is less than or equal to 3. So 0 is less than or equal to 3, and this is true. And so for the green line, I can also go to 0, 0, and that means that everything over here would be highlighted. And then what is your solution is the overlapped area. So anything highlighted in red and green. So I'm going to go over that in a highlighter. So this would be the border of that highlighted section. And then I would come down, come up, come over. And this whole area in here would be highlighted and would be a solution, which means any point I pick in that area would satisfy both equations, right? That's what that means. So the overlapped highlighted area contains your answers, contains your solutions. Okay, these are pretty straightforward. I mean, you know how to graph one line, you're just doing two of them. Okay, the next one I have on here only because the way that the problem looks is a little bit strange. So they look like this. You have this negative 5 is less than or equal to x is less than or equal to 4. So I'm going to write that out a little bit bigger. And what I want you to do is to think about this. This is actually two lines. It's two separate problems. And so what I want you to do is box off from the left to just past the variable. So you're going to box off from the left side to just past the variable. And that is one of your equations. So that's negative 5 is less than or equal to x, which means that x is bigger than negative 5, right? So if I graph this line, I'm going to use this tool right here because it's a solid line. So x is greater than or equal to negative 5, right? I like to read these from the variable. If you've struggled with these in the past, for some people these are so easy and other people struggle with these a lot. Variable. So if I read from the variable, that's actually this statement, right? X is greater than or equal to negative 5. So here's my line for x is negative 5. And then if x is bigger than that, that means I would shade everything over on this side of the line. Okay, so I'm going to do all of these in different colors. Now you're going to take from the variable to the far right-hand side in a second box. So that's where these two equations come from. And that is very clearly x is less than or equal to 4. So I'm going to graph that line. X is less than or equal to 4, which means that I'm going to have this whole area highlighted, right? Everything. And then I have these other equations here. So now I have negative 5 is less than or equal to y is less than or equal to negative 1. So we're going to do the same thing. I'm going to box off from the left-hand side to just past the variable. And then I'm going to rewrite it. Y, the bigger part of the equality symbol is near the y. So this would look like this. Y is greater than or equal to negative 5. So that's going to be a horizontal line through negative 5. And everything above that is going to... These look so gross. Varsity does a much better job of shading, and they look so pretty. And then the last one, we'll do this yellow color. We're going to go from the variable just in front of it to the far right-hand side, and that is y is less than or equal to negative 1. So that's this line here. And again, we're going to shade everything. All right, so what we have here is from let's see, this line to this line to the red line. So our only solutions in here are where all four of these intersect, and it would be that small section in there. So if you took one of these points, for example, if you took the point, let's say 0, -3, the point 0, -3. So this would allow you to check. You could fill in the top equation, which is -5 is less than or equal to x is less than or equal to 4. If you plug the x variable in there, does it actually make sense? Is -5 less than or equal to 0? Oh, geez, look what I did. Yes, it is. Is 0 less than or equal to 4? Yes, it is. So it would satisfy both of those x equations. And then for the y equation, we had -5 is less than or equal to y is less than or equal to -1. Plug in the -3 right there. So -5 is less than or equal to -3. Well, that's true. And -3 is less than or equal to -1. And that's true. So these would all check. That's what those are, is checks for you. Okay. This is question number 5 in varsity. It's got these, I think 5 and 6 are both similar. And then 7 through 12 have 3 equations. So you're just graphing all 3 of them on the same coordinate plane. Okay. That should do it. The next one, the next section is 3 by 3 equations. That's probably going to be a long video. I would anticipate getting like something to drink and something to eat and just settling in for a while. Also bring highlighters for that one. Okay. Thanks. Toodaloo.